Hey, what's up? Welcome back. Patrick here from All Things Mathematics, and moving on to the next example on the test, another communication kind of question. We have to write down the three conditions for any function to be continuous at the point x is equal to a, and then we have to show three different examples of how each condition can fail. Okay, so we went over these three conditions in the lecture videos for continuity. Hopefully you have gone through those. Basically, f of x is continuous at any x value of a if three conditions are met. So number one, f of a at that x value has to exist or be defined. Number two, the limit as x approaches a of the function has to also exist. And then also the third condition, the final one, is that both of those values from 1 and 2, they have to be equal to each other, right? So the limit as x approaches a of f of x has to actually equal f of a, like that, right? And if all three of those conditions are met, then the function is officially continuous at that x value of a. So now let's go through some examples here of how each of these conditions can fail. So how can f of a not exist? Well, a couple of different ways, right? You could have a vertical asymptote, for example. So if you think about just even y equals 1 over x, it is a simple one, right? So if we draw that graph, notice here at that x value of 0, there's an infinite discontinuity, and the condition that fails is f of a does not exist, right? Here, f of 0 does not exist, or it's undefined on this function 1 over x. So at that x value of 0, there is a discontinuity. So that's an example right there. You could also have a function maybe where, let's say you have like a hole. Let's say this is like an x value of 1. There could be like a hole there, and there could be no other solid dot anywhere else at that x value of 1. So notice in this case, there's no defined point at this x value of 1. There's a hole here. So that's another example, right, where f of a does not exist. If you were looking at this, condition 1 would be failing. Right, so different scenarios where condition 1 can fail. What about number 2? So let's say number 2, they're saying limit as x approaches a f of x exists. So how can it not exist? So let's pretend that we're going through the list, and let's say that we have a function where f of a does exist, however the limit doesn't exist. So how can that happen? Well, a simple way is that you could have a jump discontinuity. So let's say at this like x value of 2, you have a function that, let's say it stops here. Let's say this is like an x value or a y value of 3, and then it continues over here like that. And let's say this is like a y value of -4. Okay, so notice that in this particular example, at this x value of 2, just from the graph you could see that there's a jump discontinuity, but let's get specifically into the conditions. So notice that f of 2 does exist, right? f of 2 is equal to 3. Notice that there's a solid dot here. However, notice that condition 2 fails because we're approaching different y values from both sides of that x value of 2. So the one-sided limits exist. So we could say that the limit as x approaches 2 from the negative side, right, or from the left side, notice that we are approaching, as we approach 2 from the negative side, on the function we are approaching this y value of 3. The limit as x approaches 2 from the positive side or from the right side, right, as we approach 2 from the right side, notice that we on the function are approaching this y value of -4. However, the overall limit, the limit as x approaches 2 of f of x, does not exist, right? Because we're approaching different y values from each side. They have to approach the same y value in order for that overall limit to exist. So in a scenario like that, this is an example of where condition 1 passes, however condition 2 is going to fail. And then finally, number 3, how can this third condition fail? So again, let's pretend that we have a case where condition 1 passes, condition 2 passes. How can it be that both of those pass, but condition 3 is going to fail? Well, how that can happen is that you can have a hole at a specific x value. So let's say this is an x value of 2. Let's say that there's a hole here. Let's say that that hole is happening at a y value of 1. So let's say it looks like that. And then let's say that there's a solid dot up here, right? Let's say that that's happening at a y value of 4. Okay, so this is a scenario. Well, just first off, just from looking at it, you could tell it's discontinuous, right? There's going to be a hole here. It's a removable discontinuity. I have to take my pen off the paper in order to draw the function at that x value of 2. But let's go into the specifics. So notice that f of 2 does exist, right? F of 2 is equal to 4 at this solid dot. Notice that the limit as x approaches 2 of this function, it does exist as well, because if you notice, as we approach this x value of 2 from both sides, we're approaching the same y value of 1, right? So the limit exists in this case. So condition 1 passes, condition 2 passes. However, notice that both of these are different. They do not equal each other, right? F of 2 is equal to 4. This limit is equal to 1. And because these two are not equaling, the third condition fails, right? So this is an example of where condition 1 and 2 can pass, but condition 3 can fail, right? So just be on the lookout for these kinds of questions on your test. Your teacher probably wants you to relate it to these continuity definitions that were introduced in calculus, because we've gone through the types of discontinuity that can happen back in advanced functions. But they may not just want you to describe the type, they also maybe want you to go into detail of which condition here is going to fail the continuity definition. So yeah, just be on the lookout for questions like that. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.